SAS Studio provides simple and powerful ways to integrate Python code into your data preparation and analysis. If you have access to SAS Studio, I encourage you to follow along with me. Your environment might already have all the files used in this demo. However, if you don't see them, please visit our SAS software GitHub page. The SAS Viya Quick Start repository provides the files used in our demonstrations and instructions to load them into your environment. There are two different methods that you can use to execute Python code in SAS Studio. First, you can embed Python syntax in a SAS program using the Python procedure. Second, you can submit Python code directly in the Python editor. In both scenarios, we'll use a combination of Python and SAS code to import and prepare data for analysis in other SAS Viya applications. Note that the Python code you submit will be executed by the instance of Python that is installed in the SAS Viya environment, not your local client. This configuration must be done by your SAS administrator. Python packages will most likely be managed by your SAS administrator as well. Let's begin the first scenario. To open SAS Studio, select the Applications menu and click Develop Code and Flows. In the SAS Server pane, navigate to the Quick Start folder and double-click procpython.sas. This is technically a SAS program that uses procpython to execute embedded Python code, along with traditional SAS code. The Python portion begins with the procpython statement, followed by the submit statement. After the submit statement, the Python code is included. This program imports the pandas and numpy packages, then sets a DataFrame column display option. The read_CSV pandas method reads the homeequity.csv file from the SAS support website and creates a DataFrame. Under Prepare Data, Pandas prepares the DataFrame by replacing missing numeric values with the mean, replacing missing character values with the mode, creating two new columns, and then renaming columns by converting column names to lowercase and removing the underscore. After the data frame is prepared, the first 5 rows are printed using the head method. To process the data frame in either the compute server or the CAS server in SAS Viya, it must be converted to a SAS dataset. The SAS.df2sd method transfers data from the df data frame and creates a SAS dataset named homeequity_SAS in the work library. The Python procedure ends with the end submit and quit statements. Highlight the procpython step and click Run. View the log to verify it ran successfully, and preview the first 5 rows in the data frame. Once the new SAS dataset is created, traditional SAS code can be used to further process the data. In this scenario, we want to use proc_cas_util to load the data to an in-memory table so that it can be used in other Viya applications for visualization and modeling. First, the CAS statement creates a CAS session named MySession. Next, the cas_util procedure will manage and transfer data between the SAS compute server and the CAS server. The drop table statement drops the in-memory homeequity_SAS table if it exists. The load statement loads work.homeequity_SAS to the CAS server in the CAS user CASLib and names the in-memory CAS table homeequity_SAS. The list table statement lists all available CAS tables so you can confirm the table was loaded. Finally, the CAS terminate statement ends the session. Highlight the remainder of the program, starting with the first CAS statement, and click Run. The Results tab shows that the CAS user CASLib contains the new homeequity_SAS table. To view the SAS dataset on the compute server, select the Library Connections pane and expand Work. Confirm that the homeequity_SAS dataset was created successfully. In the second scenario, we'll execute a .py program to perform the same steps in the previous example. In the SAS Server pane, double-click Python editor.py in the Quick Start folder. You can also access .py programs on your local computer or create a new program. To use a local program, select a folder in SAS Server or SAS Content and click Upload to select and add your local file. If you'd like to create a new program, simply click New and Python Program, or create a new tab and click Python Program. Let's examine the code in the Python editor.py tab. The first part of this program is the same code that was in the previous example, including importing Python packages, importing a CSV file, preparing the data, and printing a sample. One key difference is that in the Python editor, you do not include the procPython step. The df2sd method is again used to transfer the data frame to the compute server. This time, the SAS dataset is named homeequity_py. Next, the data must be loaded to the SAS server as an in-memory table so that it can be used in other Viya applications. There are multiple ways to accomplish this. One option is to use the SAS.submit method to submit the same SAS code from the previous program. A variable named load_to_cas is defined, and the SAS code is stored as a string. Then the SAS.submit method executes with the load_to_cas string variable as the argument. This will run the SAS code that will create an in-memory table named homeequity_py on the SAS server. Another possibility is to use the Python SWAT package to send the data frame directly to the SAS server. The SWAT package uses Python methods and feels more familiar if you're a Python programmer. For more information about the Python SWAT package, visit developer.sas.com/open-source/Python or watch the Use the Python SWAT package demonstration. Click Run to execute the Python program. Confirm in the Results tab that the in-memory homeequity_py table was created on the SAS server. Click the Log tab to view any messages and the Python results. Let's visit the Library Connections pane and expand the work library to confirm that the homeequity_py SAS dataset was created. Again, you can use traditional SAS programming to work with the SAS dataset on the compute server. Either the SAS or Python program can be defined as a SAS job and scheduled to run at a particular time and frequency to import the CSV file, prepare the data, and load it to SAS. With the home equity table loaded into memory and promoted to global scope, it is available for further processing and analysis in other applications, such as SAS Visual Analytics or SAS Model Studio.